graphics-intensive games.
Okay, graphics-intensive games is one.
Sometimes like converting between different video formats or something like that.
Okay, conversion between video formats, also known as transcoding. Yep.
Web browsers like that.
Web browsers. Yep. Depending on what you're doing in the web browser. Yep.
I find that Photoshop is quite advanced.
Yes, Photoshop, especially when you're processing huge files, it can use up a lot of resources. Go ahead.
AutoCAD.
AutoCAD. Well, yeah, AutoCAD when you're changing perspective and doing 3D modeling, that certainly can be compute intensive. Yep. Compiling code. Okay, that's kind of like a topic that most of us do not know yet. What that process is. But yes, recompiling, let's say a kernel, an entire operating system can take up your computer for hours. If you have a fast one. Yep. Rendering. If you use anything like what's the name of that rendering software that's free, open source? Blender. That's it. Thank you. So if you're using Blender and you're making a movie out of Blender, that can also take up a lot of processing resources. So the quick question is, when you have these heavy-duty applications that require a lot of processing time, do you still want to do something else in the background when Blender is rendering? No. Do you still want to check your email? Maybe. Okay, check your email and do some of the other things that does not require a lot of processing resources. Sometimes we may want to. Okay, let's just say that we may want to. You want to have the choice. Okay, you don't want to say when I'm transcoding, I cannot do anything else. Okay, you want to be able to do something else if you choose and say, okay, when I'm transcoding, video formats, I still want to be able to go online, do some simple stuff like checking email or reading the news and stuff like that. So the operating system is responsible to make sure that no application can quote unquote hog the processing resources. Okay, the actual mechanism of making this happen is kind of technical, and I'm not going to talk about it. It's called time slicing, and there's a whole lot of stuff related to it. But I can just say that the operating system is responsible for that. Okay. The resource is allocated by priority, and more important programs get the resource before others. Okay, and at this point, I'm not going to talk about why we have different priorities here. The second resource that an operating system has direct access to would be memory. It refers to the availability of RAM, or RAM stands for Random Access Memory, to store data temporarily during processing. An operating system manages this resource so that a program can only access memory that is allocated to it. Okay, it's kind of like I can see some of you are taking notes. Okay, which is a very good thing. Every application program can request the operating system and say, "Can I get more binder papers, please?" Okay, and most of the time, if there's enough binder paper from as a resource in the system, the operating system would just go, "Okay, here's a pile of 10 more pieces of binder paper," and give it to the application programs. So each application now has a pile of binder paper, to work with. That's basically RAM. The question is, do you want your neighboring, peer, the next student, to be able to clobber over your notes? Probably not, right? And it's the same thing when it comes to programming. Okay, when it comes to application programs, you don't want an application program to be able to access memory that belongs to another application program, because that can cause like really massive failure. Because if one program decides to misbehave, it can clobber everybody else's memory and make all the other programs crash. Okay, let me just kind of turn it into an analogy in the class. So let's say out of this entire class, everybody is well behaved and just minding their own business, taking notes and whatnot. Okay, one person decided to bring a can of spray paint and say, "I'm going to spray paint everything in the class," and just walks over and goes shh, like that. We don't want that to happen in the classroom, and we don't want that to happen in a computer either. So basically what an operating system does is it automatically establishes a quote-unquote force field around each person. Okay, so each person has your own space, the binder paper, it belongs to you. If you want to scribble on it, if you want to spray paint yours, it's all okay. Okay, it's yours, but you cannot touch the binder paper of another student. Okay, and that's what an operating system does too. Is it helps to make sure that each application can only use its own memory. Okay, so an application program can crash itself. Okay, if it doesn't manage its own resources correctly, it can crash, but it cannot crash everybody else at the same time. Is that okay so far? Okay.
So it's not a virus.
A virus, becomes a virus because it can actually gain a higher level of access to the operating system itself. So a lot of times a virus, is very insidious because it's not just running as an application; it's actually, gaining access to a more core portion of the operating system. That's also partially why in Linux I cannot save a file to folders where I do not have access to. Okay, because if I don't have access to key portions of an operating system, a virus cannot spread to the operating system itself. Yep, go ahead.
What about when you take like a blue screen of death, right, when it's loading up the
Okay, the blue screen of death of Windows is basically the operating system itself crashing. That can be many different reasons. In fact, when we get to the next portion, the contractor concept, a lot of times it has to do with software drivers and not Windows itself. But when you get the blue screen of death, it means the operating system itself is not operating correctly anymore. In other words, the government itself is not working anymore. It has crashed. So it drags everything down with it. Yep.
You said that when an application crashes, it doesn't affect the other apps. I have Shockwave, and when it crashes, it affects some of the other tabs.
Do you know why? Because all the Shockwave applets, all the instances of using Shockwave, they all share resources. So that's why when it crashes, it takes everything down with it because they're all really the same. They're all coming from the same application. So when you play Shockwave from this website and you play Shockwave from the other website and you play Shockwave from yet another website, the three instances are really sharing the same core portion as an application. So if that application crashes, then it will affect all three instances. And if it is inside a browser, it can also cause the browser to misbehave because the browser may not be able to handle a Shockwave applet or embedded application crashing. Okay. Yep.
So that when you use a flash player and then say you need like macromedia or something, but it won't work together on some video. It's the same thing like with Shock.
Yeah, Shockwave, and Macromedia, Flash, they're all kind of related. There are ways to enhance your web experience, because otherwise your web experience will be all text and there's no video, there's not as much interaction. Yep. So Flash.
If I use it, I watch like a video on something, it'll like everything is okay, and then I go on another site and the words don't match them out.
Okay, so you either have, in that case, when you're watching a video and the audio doesn't match the video, it can be several reasons. I would look into updating your Flash player first. Okay, making sure your Flash player is updated, and then it can possibly be because your computer is too slow, because usually it's the video lagging behind the audio. Is that the case? Yep. So that's because to render video takes a lot more resources than rendering the audio. So that's why sometimes it can lag behind a little bit. Yep.
You were talking about permissions, security permissions, so that the program can't be malicious or crash other programs. And I heard with like Android and other mobile devices, the operating system, you can't really get.
Okay. Excuse me. I need to hear what he's talking about. Okay. Yep. Go ahead.
That you can't really get a virus on the OS itself for a mobile device because of the way the permissions are set up.
Mm-hmm.
And then all the programs are actually in a way a little bit a mini OS because they run themselves in their own environment.
Right.
Okay.
That is correct. In the Android environment, each application is a Java virtual machine. So it's running inside its own virtual machine, which makes one application being able to hack into the other one much more difficult. Not that it is not possible, it's just a whole lot more difficult. Okay. Yep, go ahead.
In his example, is that analogous to the government being a state agency?
It's just more containment. I think sometimes it's harder to find real life analogy. So in the case of a virtual machine, it's almost like each person has that person's own space that doesn't connect to the other spaces that other people live in.
So it's like Hawaii, its own island. So
If you watch Star Trek, it's kind of like each person has his own reality bubble. And then the other thing is a program cannot, I actually phrased this wrong. A program can request more memory than the system has available. It will just be denied. Okay, so it can make the request, but it won't be able to get the resource because there's not enough resources. All right, so the next topic is even more interesting because there are resources that are not inherent or core to a computer. In other words, these resources are peripheral to a computer. And these components may include hardware to do with display, sound, storage. Even the hard drive is peripheral to a computer, networking, and so on. Now, there's a big problem here. Okay, the big problem here is even though there are different manufacturers of random access memory, RAM, and there are different manufacturers of the processors. Okay, we have AMD, we have Intel, and then within Intel they have different variations. But from the software perspective, they're all pretty much the same. Okay, whether you buy your RAM from OCZ or some other OZ. Okay, what is the manufacturer? Is that OZZ? Okay, which manufacturer makes it doesn't matter because it still works pretty much the same way. It's kind of like with a car. The wheel and the tire are core to a vehicle, to a car. Okay, so whether you use Michelin, which particular version of Michelin, doesn't really matter. Okay, it is still just tire. Now, some tires have more traction, some tire has less traction, better wear, tread wear, and so on and so forth. But for the most part, it serves the same purpose. But in the case of peripherals, it's not really quite the same because the peripherals can be very specific. The way to use each type and each brand and each model of these peripherals can be different from the next one. And there's a lack of standardization. Okay, so the way to utilize or fully utilize an NVIDIA display controller will be different from how to utilize an ATI. Now, who owns ATI now? AMD. Okay, but it will be different. Okay, there is a standard. There's a standard called VESA and VGA. But if you want to use the VGA standard, which is common to all display controllers, why would you spend hundreds of dollars on a video card? Because in VGA mode, the computer it can only display up to 1024 by 768 or one of the common resolutions, and you will miss all the 3D acceleration. All the acceleration you are getting that you're paying money for will be missing when you use just the standard feature of a video card. When you buy a $500 video card, I'm assuming that you want to extract the most performance out of it, right? And to do that, the method to utilize all the resources available in a video card